confident if I'm sure you guys are good at triangles, then I'll be able to do the other part of trig, which is the graphs and whatever. But we're focusing on the shapes. So let's just go. The moment we see triangles, we're going to stop. Okay, this is a trapezium. We talked about it, but I'm not going to look at it right now. Trapezium is not a triangle. You don't need triangle for trapezium. Right. Are you all hearing me? Can you all hear me all right? And so, yes, this is the 2026 February March paper 22. So I'm going to do from this to paper, then we go back all the way. So this is the first question we are doing, 2026 February March paper, and we are going through this paper 2. So there's paper 2, then there's paper 4. As soon as we can have the 2026 May, June, we'll use them. So this is a right angle triangle. What we do know is that when there is a right angle, then you try, once you see a right angle triangle, you write Pythagoras, and you write SOHCAHTOA. These are the two methods that work for right angled triangles. There's no other method. These are the two methods that work for right angled triangles. So one of them has to work here. Right, give me a second. Let me make sure everything is perfect here if I do this. Right. All right, good. I was fixing the ratios for the live stream. Now, what we were saying is, here's the first one. So you write Pythagoras and you write SOHCAHTOA. So I'm going to be moving very fast. Make sure your calculators are around. Make sure you calculate with me very fast. You put your answers in the chat and we move on. Okay, I want attentive people. We move together because it's going to be you doing the next questions. So once you see a right angled triangle, these are the methods to solving triangles. You use this when you do your questions. Once you see a right angled triangle, you write the word Pythagoras and you write the word SOHCAHTOA. Now we say the only time you do Pythagoras is if you have two sides and you are looking for side number 3. Why? Let me fix. Let me see. Can you hear me? Can you hear me? All right, so we do Pythagoras, we write SOHCAHTOA. Now, what do we do after writing Pythagoras? After writing Pythagoras and SOHCAHTOA, what do we do? Well, we test Pythagoras. That's the one we test. For right angle triangles, we test Pythagoras. Do you have two sides? Remember, for Pythagoras, before you write it, you check, do I have two sides that I know already? Two sides. For Pythagoras, you must have two sides that you know, and you must have one side missing. Two sides known, okay, they must give you two sides, and you must have one side missing. The question must ask you to find the third side on a right angled triangle. Here I only have one side. I don't even have two sides. So this is definitely, okay, this is definitely not a Pythagoras theory question, because I have this one side, I can't have another side. So Pythagoras, you are out. So automatically it has to be SOHCAHTOA. There is no other method. So we write SOHCAHTOA. Okay, it has to be SOHCAHTOA. Now, when you write the word SOHCAHTOA, well done. You have chosen the method correctly. You've seen that it's SOHCAHTOA. What do? You label now. Now, after writing the method, it's time for you to label the way we do in SOHCAHTOA. Opposite the corner of the right angle is hypotenuse. Opposite the angle is the opposite side. The third side is adjacent. Now, which side is not being asked in the question? Which side is not part of this question? Which side is useless now? They want you to find AC. And you can see that AC is this one, the hypotenuse. So we need him. And we have been given the adjacent. So opposite side is the useless one. You should always find, after labeling, you should find the useless side, which in this case is the opposite side. So it's useless. So anywhere where we see the O for opposite, we cancel. That means for this question, the only way to get the answer is to use CA. So you now write cos theta is equal to, this is what you now write with the pen. What you give to Cambridge is adjacent over hypotenuse. I want to see this type of working in the work I'm going to give you, right? You got to submit. And I'm going to be hard on you, okay? And I'm going to be hard on you, engaging both you and your parents. Let's see now. We are looking for hypotenuse, students. We are looking for hypotenuse, which is h. We swap it with cos theta. That's the only way, because it's in the denominator. So we want it. We swap it with cos, it becomes hypotenuse is equal to adjacent over cos theta. If what you want is in the denominator, you have to swap, like what I've done here. So this is going to be, what is our adjacent? 12. So hypotenuse is AC. What is our adjacent? 12 over, what is theta? 30. So over cos 30 degrees. Make sure your calculators are in degrees. You have the DRG button on your calculator. This is what you use to convert to degrees and radians. Press it, this DRG, the button which says DRG, until the top of your calculator says degrees. Then I want you to say 12 divided by cos 30 and tell me what you get. And put it in the chat. Everybody, I want to see an answer. Come on now. You have your calculators close by, and I want you to be putting the answer in the chat. Let's go, everybody. Let's get the chat moving. Welcome, everybody. Let's get the chat moving. Put the answers. What is 12 divided by cos 30? What is 12 divided by cos 30? I don't want to see one answer or two answers or two answers or three answers. I want to see the whole group. We move as a group. Come on now. Okay? You're still young and fresh. Let's go. Give me my answer. Seth. Everybody. Sibu. Where's the answer? Come on now. Please put my answers, everybody. Kelly, put the answer, put the answer. What are you getting? What are you getting, people? Simon, Lucica, what are you getting? Kevin, Balloon, what are you getting? Okay, good. 13 point. I'm seeing some answers. More people. That's what I want. I want everybody to be part of this. 13.86. Everybody has to be part of this. And you say centimeters. So this is a good answer. Okay, or to 3 decimal places, this would have been 13.9. We'll confirm with the book when we are finally. Let's check at the top. Let's check at the top. So you know what to what. They wanted to what decimal places. Let's see. We'll go to the top. Let's see at the top. Make sure your calculators are. Make sure your mics are muted, everybody. To how many decimal places? Oh, all right. Good. Actually, don't worry. I'll teach you. Because this is the non-calculator paper. I'll teach you how you're going to get the answer, don't worry. But yeah, here's how you're going to get the answer. Let me teach you, because this is the non-calculator paper. Everybody, pay attention real quick. You have to know sine and cos. Okay, of these angles. I need you to know sine and cos of these angles. So easy. 0, 30, 45, 60, and 90. Everybody, you have to know the sine and the cos today of these angles. They are not the ones you put on a graph. You use them in calculations if they give you in a non-calculator paper. All right. So here's how you do. You start at 0. Then you go. Everything is over 2. So it will be root 1 over 2, which will become a half. Then there is root 2 over 2. Then there is root 3 over 2. Then there is 1. So it's 1 over 2. It's because it was actually a root 1 over 2. So let me teach you now to put it nicely so that you can be able to simplify it, right? Let me teach you. Let me make it bigger. I want to make it bigger here. This table is the most important one. You're not going to let me down, everybody. You're not going to let me down. I'm making it bigger for a reason. This is the easiest thing ever. Sine and cos. In maths, these are called special angles. Angles that you must remember are called special angles. It's 0, 30, 45, 60, and 90. These are called special angles. 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. We'll do the same exercise in radians next time. But if you have an IGCSE student, you have to know them. We are not begging you, we're telling you. 0 degrees for sine is 0. So sine counts up 0, then root 1 over 2, put it at the corner, then root 2 over 2, then root 3 over 2, then 1. So, which means that root 1 over 2, I want you to know it simplifies to be half. So when we say sine of 30, we will get half, but it's from root 1 over 2. Then this root 2 over 2, sometimes we simplify it to become 1 over root 2. It's the same thing. Then root 3 over 2, we use it as root 3 over 2. Then we use 1. So you must know the original version, root 1 over 2, which is actually just a half. Root 2 over 2, root 3 over 2, and then 1. So you should know how it follows a pattern. Then for here, it would start vice versa. 0 here, then what? Root 1 over 2. Then here, root 2 over 2. Then here, root 3 over 2. Then 1. So cos counts backwards. It's the same thing, but it counts backwards. And that's how you'll be doing. What is root 1 over 2? Aki, what is root 1 over 2? I said you simplify to be what now? What is root 1 over 2, students? I said you simplify it to be what? Look at put it in the chat. Put it in the chat. I said you simplify it to be half. Root 2 over 2, I said you simplify it to be 1 over root 2. Root 3 over 2, yes. Root 3, well done. And root 3 over, okay, good. Good, 0.5, which is half. Well done. That'll be it. So you can see this, and these are the things. So I want you to know, so that is what we would have done here. We would have said we want cos 30, so we just go to our table, which we would have constructed. We know how to construct. And you see it to be root 3 over 2. All right, so you could say this is going to be 12. It would be 12 divided by root 3 over 2. Divided by root 3 over 2. When you go to the table, you see which becomes, if it's 12 divided by root 3 over 2, what does it become? When you're dividing by a fraction, okay, because this is 12 divided by, then you put root 3 over 2. When you're dividing by a fraction, you multiply by the flip. So you now say AC will be equal to 12 times. You now flip 2 over root 3. Okay, you now flip it, which becomes 24 over root 3. Which becomes 24 over root 3. Like this. Okay? This is one way. And they said express your answer in the form A root B. This is pretty much what we have. Let me show you what should be. So it'll be 24 over root 3. This is good. This is your solution. Now let's see. Find the shortest distance from B to AC. They want the shortest distance from B going to AC. Basically, let me tell you what they want. This distance here, which goes the shortest, whenever they say shortest distance, just know that, do me a favor. Listen. If they say find the shortest distance from somewhere to somewhere, it should make a right angle, or else you're wrong. So basically what we are saying is, we start from B, and we go to the line AC, but when we get to it, it should be a right angle. So let's do it and let's see. We go from B, we get to AC, but it makes a right angle because it's the shortest distance. Once you see a right angle, you can tell this is the height. So now I can remove things and I can say, this becomes the base and this becomes the height. So, okay, that's fine. Now we want to find this height, this h here. Okay, we want to find this h. How do you find it? Let me put it like this. How do we find it? We use this right angle triangle here. We use this right angle triangle to find this height in this edge, which I've highlighted in green. We use the triangle. Why do we use it? Because it's a right angle triangle. So we remove everything. We are doing a new right angle triangle now. Right? We are doing a new right angle triangle. We write Pythagoras and we write SOHCAHTOA. SOHCAHTOA. Now let's see the triangle in purple and green. Do we know two sides? Before we do, do we know two sides? No. We know the whole of AC, but we don't know this one. We don't know from here to here. Okay? We don't know it. So this one we don't know. So we don't know. We only know one side, which is 12. So that means Pythagoras is out. To use Pythagoras, we must know two sides. And we must be looking for the third one on a right angle triangle. So automatically we are using SOHCAHTOA. So you write SOHCAHTOA is the method we are using here. Once you have chosen the method, label your triangle. Label your triangle. Opposite the corner of right angle is the hypotenuse. How did you know this was a right angle? Because they said shortest distance. They said shortest distance. So this is hypotenuse. Then opposite the angle is the opposite side, which we had called height. We remove. So this is the opposite side. Then this third one is here, which is the adjacent. So now, which side is not going to work for us? Which side is it that we don't even want? Hypotenuse, we want it. It is 12. Opposite, we want it, is the one we are looking for. Adjacent has nothing, so it's out. So anything with A for adjacent, we take it out. And we are going to have to use so. For us to do it here, we have to use so for this question. So what is so? It's sine theta is equal to opposite over hypotenuse. which is equal to, what is your sine theta? Theta is 30 degrees. So you say sine 30 degrees. Okay, since we are looking for opposite, so we can take hypotenuse to the other side before. So we'll say sine theta times hypotenuse is equal to opposite. You don't have to swap because opposite is at the top. You just take hypotenuse to the other side. Sine theta times hypotenuse is this. So sine theta, what is theta? 30 degrees. Times, what is the hypotenuse? 12. This is O. Which is, what is sine 30 degrees? You go to your table, you find it being half. If you go to this table, sine 30 is half. Okay? Which is equal to the opposite side. Half times 12 is like to say 12 times 1, then divided by 2. This is equal to opposite, which is 6 centimeters. This is the opposite side, and you're done. So it is 6 centimeters. And you get your 3 marks. So what would be a problem here is you won't be understanding if somebody didn't understand what it meant to say they want the shortest distance. Shortest distance makes a right angle. Then check the triangles there. You check the triangles now. You check the triangles. Then you see which method are you using. Triangles, really? These are not a problem. It's a simple shape. All right, so here they didn't have any other question on it. Let's go to the paper 4 that was written this year, literally 3 months ago. Okay, February, March 2026. There we go. We go to the paper 4 now. February, March 2026. There we go. Paper 4. Let's see questions on triangles. Here is a triangle. What do they want us to do on this triangle? It is a right angle triangle. Okay, it's a right angle triangle. They said ADC is 74 degrees. Okay, there's nothing here. Okay, it's a right angle triangle. Everything written here, we don't have to read it. We can see it for ourselves on the diagram. So now let's see what they want us to find. Well, without thinking, remember, the secret to answering questions is you have to put anything that is missing before you are asked. Before you're asked, because you may need it. So how do I find the value of x? One thing I know, this is actually not really about triangles. It's about geometry. They're trying to see if you understand geometry. More of geometry than trig. So here, they want to see, do you know that the whole angle on a straight... Pardon? Oh, it's because they're useless. Let me say it like that. I don't want to say they're useless, but they will confuse you. You don't need them, basically. Okay? You don't need them. You don't need, because everything in those words is in this line here. I'm talking about for this particular question. So is in the diagram itself. You know that the angle on a straight line is 180 degrees. You have 74, so you say x will be equal to 180 degrees minus 74 degrees. What do you get? 106 degrees. So x is 106 degrees. Then to get y, first I gotta get this one here, okay? Without thinking. Once I have 74, I have 90, I can get this one again. It's the same method. Triangle also adds up to 180. So if I'm going to call this z, I'll say to find z, it will be 180 degrees because a triangle adds up to 180. Because these are in a triangle. They are in a triangle. They add up to 180 degrees. So you say 180 minus 74, you get at 106 degrees. Then now you see that this is a straight line. This is a straight line, which is again 180 degrees. To get y, you say 180 degrees minus z, which is to say 180 degrees minus, what did we find for z? 106 degrees. No, Z. How can Z be 106? Sorry, for Z we didn't do it correctly. We were supposed to say 180 minus 90 and 74 because there is a right angle which is 90 degrees. So it's 180 minus 90 and 74 together. Okay, minus 90 and 74. You're subtracting the two of them, so you find Z. What is the answer? We're about to put the wrong one. What is the answer here? You're allowed calculators in this one. It's a paper 4. Come on now. What is 180 minus, in brackets, you say 90 plus 74. What do you get, students? Put it in the chat. Put the answer in the chat. Come on. If you don't want to put the answer in the chat, then you have to settle with me calling your name randomly. What is the answer? What are you getting? $16 degrees. Which means to get Y, so we have found Z by saying 180 for the triangle, then we remove this 90-degree angle and the 74, then we got 16 degrees for Z. Now we know that the angle on a straight line, the whole angle, is also 180 degrees. So to get Y, you would say 180 degrees minus 16 degrees for Z. What do you get? You get Y being 164 degrees. So Y is 164 degrees. That is going to be our Y, 164 degrees. Okay? Are we together? $164 degrees. So that's good. Now we go on looking for triangles. Give us triangles. Come on now. We are asking for triangles. Here are the triangles. Here are the triangles. Oh, there is no right angle on both of them? Really? So I'm going to write the word cosine rule and the word sine rule. Okay? Now, calculate area of triangle ABC. Well, we know how to get area of a non-right angled triangle. We know that to get area of a triangle, this simple shape, we have 3 ways. Only 3 ways. This one is when you know base and height. You have a right angled triangle. Area will be base times height over 2. This one this is also base times height over 2 because you have the base and you have the height, the shortest distance to get something. That's the height, then you have the base. You can still get area. Then the last one is for non-right angle triangles, and this will be theta, this will be A, this will be, you'll be saying area will be, you take this side, you multiply this side, so it'll be A times B, then you multiply by sine theta, then you divide everything by 2. You divide everything by 2. So, calculate the area. Everybody can see that this is our A, this is our B, this is our theta. We are using method number 3. We don't have any base and any height. Don't force it. If you had height, they would have given you this one and shown that it forms a right angle and whatever. So this is going to be area. We use formula number 3. So we'll say area is equal to, what is our A? 600 meters. Times, what is our B? 450 meters. Times sine 57 degrees all divided by 2. So this 600 by 450 by sine 57, all divided by 2. What is the answer, students? Can you punch it exactly like this? Make sure your calculator is in degree mode and put the answer in the chat. Put the answer in the chat, everybody. Come on now. 600 by 450 by sine 57 divided by 2. What's the answer? What's the solution for area? Clive Bondi. Can you tell me the answer, please? Clive Bondi? Did you hear me, Mr. Clive? Okay, there. I'm saying 113,220.5. 113,220.5 square meters. All right. That's good. I want to see answers coming all the time. All right. Okay, that's good. All right. This is the final solution. Show that angle, whatever. If they say show that angle CAD is this, they're just trying to say find angle CAD. Let's go and see which angle that is. So we erase this. Angle CAD is in here, is the angle at A. Okay, because they say it's CAD, which means it's at A, but it's in triangle CAD, this triangle, CADC. So we want the angle CAD. So this angle here, so even if I call it theta, this is the angle they want. I'm going to go to the angle and call it theta. It is in triangle CADC. The triangle is called CADC. We want the angle CAD, the angle at A. Now, look. You just analyze the type of triangle you have. Don't change the method. Oh, it has no right angle. So I'm either going to use the sine rule or I'm going to use the cosine rule. Because there is no right angle. Now, check the situations for cosine rule. Cosine rule, I want you, when you write it, I want you to say included angle. It should either have an included angle or it must have all 3 sides. This triangle of yours must have all 3 sides. Let's look at this one. Does it have all 3 sides? No, it has 2. 290, 450. It doesn't have this one. All right, so this one is out. What about included angle? Let's look at the angle it has. Angle is 34. Is the angle included? Do you know the 2 sides that go to make it? That's what included means. We know this one, 450. The other side that goes to make this angle is not there. So 34, I'm sorry, you are an angle, but you are not an included angle. So there is no included angle, which automatically means we are doing the sine rule. Cosine rule is out. Sine rule is the one we are doing. Now you do with the pencil before you go. What letters do you have? You have A, you have C, and you have D. So you're going to say sine A over small a is equal to sine C over small c, which is equal to sine D over small d. Like this. Now, good. This is the sine rule. Because you see, it's a sine rule question. There is no included angle. There, you don't have the three sides. So cosine rule is not going to work here. This is obviously sine rule. Right. So now this 2026 paper, by the way, everybody. Now, your job after choosing the sine rule and writing this one is to label the triangle for one more job. So let's label the triangle. Opposite big D, small d. Opposite big C, you go opposite big C, you go to the small c corner. You go opposite big A, you're going to small a. So now, what is missing here? Which part is not even going to help us to find anything? So let's work around it. Let's see which side. C, you can see that we have been given C. Okay? And whatever. D, you can see that we have been given D. A, you can see that we have not been given A. But we want the angle opposite A, the angle big A. So that means, well, since we don't know both of them, we don't know the side opposite and whatever, we cannot find it for now. What we can find is this one. So let's call this one alpha. We can find alpha because the side opposite him is there. So we can find it. And these two know everything. So for now, A is the one which is out. Okay? So A is out. So anything to do with A is out. So we are using C and D. Remember, you can only use 2 per question. 2 per thing. So you're going to write sine C over C is equal to sine D over D. Sine C, which is sine big C. What is that big C? It is 34 degrees. So it will be sine 34 degrees divided by here it is. We say sine 34 degrees divided by 290. And it will be equal to sine of this capital D is alpha. So this would be sine alpha over small is 450, and that's it. So now you got to find alpha. You take 450 to the other side. You say 450 times sine 34 here. You can see 450 times sine 34 over 290. What do you get as your answer for sine alpha? Can somebody say 450 times sine 34 divided by 290? What's the answer, students? The answer. Yes. We'll do sine inverses the next stage. First, I want this one. What is the solution here? What is the solution? Put it in the chat. 450 times sine 34 divided by 290. Yes, you should get 0.86771 whatever as sine alpha. So here now, we need to find alpha, so we'll take sine to the other side. It becomes, you write it here, sine inverse of 0.86771. This is equal to alpha. What is this going to be? What is the solution? Can I get the question, Kosi? The solution? Kosi? Students, only 3 people have given me the answer now. 4. Where are the other 17? Where are the other princes and princesses? Come on now, my superstars, give me the answers. Make sure your calculator is in degree mode. And I want you to say second function sine 0.8677 whatever. Okay, 60.2 degrees. So what's the problem? You see, sine rule is quite easy. Yes, now I'm beginning to be happy. That's what I want. Participate. Simon and Lehakwa, you haven't participated in this last round. Come on now. All right, so 60.2 degrees is the solution. You have done very well. All right. Now, there's more. This is a six-mark question. Let's see what it says. Calculate the angle of depression of the top of the mast at point D from the top of the mast at point B. Okay. I'll do with you this one and explain one or two things. But I want to just do the small ones that we are doing and try to do as many as you can. And I want to give you to try these to see if you are doing the triangle correctly. The triangle is a small shape. You can't tell me you're failing to master the rules of a triangle. Come on now, students. Here is a triangle. And it's going to be very similar to what we've seen because it says shortest distance from Q to PR. So we just put that distance from Q to PR. We don't know it, but what we know, there is a right hand. Pardon? Yes. Yes, I will do it. We'll do it. Don't worry. We will. Yes, we will. We will. I want you to do these ones first. I want you to do first. Yeah, we're gonna do it first. I want you to do these that we have mastered first. Okay, I'm going to do it. Don't worry, I've already seen it. I will not leave it. There's no way I'm gonna leave it. But I want you to do these with me first. Calculate the shortest from Q to PR. So you can see that this is a right angle. Okay, because once they say shortest, it has to be a right angle. And everybody can see that we know some information about this right angle triangle. We know this side 12.5, we know 42, and now we can find this one, which if we want to call H, you can call H, or whatever you want to call it. Okay? We can find it because we have enough information in this green triangle. We have the angle, we have another side, so yeah, it's good. Now, this is a right angle triangle that we are trying to solve, so we find this missing length here. So once you see a right angle triangle, you quickly write the word SOHCAHTOA and you write the word Pythagoras. Pythagoras. Now, once you write SOHCAHTOA and Pythagoras, you see, can I use Pythagoras? Do I have two sides? Do I have two sides in here? No. Okay. So now, here we are doing it. We got a label. We see that we don't have two sides here. There are no two sides that we know. So we cannot use Pythagoras. So we use SOHCAHTOA. Now we label according to SOHCAHTOA. Opposite the right angle, hypotenuse. Opposite the angle that you know, opposite side. The third one, adjacent side. Now you want what? The opposite side. Oh. So you're going to say, okay, I want O, the opposite, which is the shortest distance, which is at O. Then you want A. So this is out. Which means now, what are you going to write? Adjacent is out. So wherever there is adjacent, we bring out in SOHCAHTOA. We write, so it's going to be sine theta. Sine theta is opposite over hypotenuse. We want opposite, so we take hypotenuse to the other side. Hypotenuse times sine theta is equal to opposite, which is 12.5 here, 12.5 times sine 42 degrees. This is the opposite. What do you get? 12.5 times sine 42. What's the answer? May the answers come in the chat, please. Hello, Esther Benedus and leader. Tell me, what is the answer here? Put it in the chat, everybody. 12.5 times sine 42 degrees. Where are the other solutions? Set. Okay, I just saw. So you can say 8.36. So this is easy. Nice triangles here. Here's the next question. Same paper. Okay? I'm going to give you to do yours. Now, once I see I have two triangles, there is no right angle, what do I write? Cosine rule and sine rule. These are the ones that work here. The cosine rule and the sine rule. Now, they want you to find the first one. Find AD. They want you to find this one. What I want is to make sure you are thinking correctly. You have the correct thought process. Okay, you want AD. Which triangle is it in? Okay, because these are not just flying, they are on triangles. Here is the triangle in purple and green. Okay, now let's see. Do I have all three sides? Listen. Listen, students. Mathematicians. I never said the method depends on what on the side they ask you. No, I never said that. I never said the angle will depend on BD or BA or AB or whatever. That's not what it depends on. The method you use for any question, whether they ask for angle or missing side in your right angle, depends on what information was provided. So your job is to look at the information provided. Look, we know that to use cosine rule, we must have either an included angle or we must know all three sides. You must have all three sides. Let's look at triangle ABD. Do we know all three sides? No, this one is not known. Okay, so all three sides is out. All three. Do we have an included angle? Yes, an included angle is where you know the angle and you know the two sides that come to that angle. So let's check 56 degrees. Is it an included angle? Yes, because we know this one and we know this one. So automatically we are using the cosine rule. Cosine rule, we are using U. Now let's use him. We are going to say, who do you want? You want AD. So it's the missing one, AD. You square it. It is equal to the other two guys squared. So now we are writing the cosine. We have seen that we should use it. Now we are writing it. I taught you how to write it. The one you are looking for, once you see you have an included angle, you have an angle and you have the two sides that make that angle. That's an included angle. You use the cosine rule, no matter what. So here we say AD is the one we're looking for. We use the cosine rule. AD squared will be equal to the other two, 9.6 squared plus 12.1 squared. Okay, you add the other two. Then you say minus, then you open a big bracket. Then you say 2, then you bring 9.6, just one of them. Then you bring 12.1, just one. Then you say cos 56 degrees. Yes. Like, no, it doesn't matter. It doesn't matter. Let me think. Yes, it matters when you. No, it doesn't matter which one is written first. 9.6 and 12.1 are just fine. Don't worry about them. I'll show you why. Doesn't matter. So the order doesn't matter. You should just make sure you add before you subtract. And do well. So our AD all squared will be equal to, You can punch this right now and tell us the answer. What do you get? Punch it exactly like this is. Tell us the answer. What's the answer, others? Tell me. Kosi. Pakiso. What is the answer for this one? Where we are using the cosine rule? Okay, put all the significant figures because this is not yet the final solution. So put all the other significant figures that come after the thing. What are they? Put all the others. Put it too many SF. Is it exactly 1.108.65? Simon. Ooh, Lusika, you can't see the screen. What's going on? Okay, Lusika, let me send you the link to the YouTube. What is it? All right. What is the 3-1? Anu, did you put it exactly like this, Anu? Did you put the brackets exactly the way I did? Anu? Ooh, something is wrong. Your answer is too big. Your answer is too big. Try again, try again. Put all the brackets. Say 9.6 plus 12 squared plus 12.1 squared minus open bracket. 2 open bracket 9.6 close. Open another one 12.1 close. Cos 56 degrees close. Tell me what you get. All right, so 1.108.65830, 108.6583047. Then to get AD now, we got to take this squared to the other side. So to get AD, we now need to take the square to the other side. It becomes square root of 108.6583047. Can somebody tell me what the final solution becomes? Tell me now. Come on now. Put in the chat. Put in the chat, everybody. Use the chat. Use the chat. Okay, Seth, I see you on YouTube. Lusika, can you see you on YouTube now? Are you on YouTube as well? Okay, good. Put the answers. LGK, Lehakwa, can you personally tell me, please? I'm waiting on your answer. What is the square root of 108.6583047? 10.4 centimeters. Oh, 10.4 is not the full thing. 10.49. How does that become 10.4? So this would be 10.5. Round off, students. Come on. Oh, 10.423 centimeters. Which, yes, you can round off to 10.4 when you do to 3SF. All right. Now, let's go. Now, let's go to the next. Find this angle, BDC. So I'm not interested in the question. I'm interested in the triangle. Okay? Well, thank you for asking me to find the angle at D. I'll find it. Don't worry. But I'm going to go to the triangle which joins BDC and back to D. So which triangle is that? From B to D to C, then back to B. So this is the triangle. So the triangle which joins that. That's the triangle I'm interested in. I'm interested in the triangle itself. I found it. Now they want the angle at D. They want this angle here. Can call it theta. The angle at D. All right. So I've seen the angle at D that they want. Now, let's see what method do I use. I have cosine rule, which uses these, or I have the sine rule, which is for any other situation. So first I check. Do I know all three sides? This is a non-right angle triangle, so that's why I know it's cosine rule or sine rule. Do I know all three sides? No, you don't. Boom, it's out. Do I have an included angle? Let's check the angle 47 if it's included. 47, are you included? I know 15.8, which is the side that comes to this side. What about the other side? Because you must know if an angle is included, it means you will be knowing the two sides that make it. So I know this one, but do I know this other one? No. So it's not an included angle. So I don't have an included angle. Automatically, I'm using the sine rule. I'm using the sine rule. Now, when you're using the sine rule, check your letters. You have B, you have C, you have D. So it will be sine B over small b is equal to sine C over small c, which is equal to sine D over small d. These become the letters. These become the letters. Now, you need to choose one letter which is not part of the question. So in the last one, I don't remember. Something has quickly risen in me. In the last one, I think we didn't. We lazily finished it. Did we finish the whole thing? Let me go to the last question we did. Wait. Something has quickly come back. Before we write wrong things together. Oh, yeah. In the last one, with the sine rule, we got 60.2, but it was not the one we wanted. 60.2 was this one. Degrees. All right. I just remembered. This is 60.2 degrees. They want this one here. So to get this one, you're going to say 180 theta, okay, to get the angle at A, because they wanted the angle at A. Okay, it just came back. How come you guys didn't tell me? Angle CAD becomes now 180 minus 60.2 minus 34. Okay, It's minus 16.2 and 34 together because they are the two sides, okay? What is that going to be? You should get 85.8. We're already predicting the solutions. This becomes it. So you get your 4 marks. Wow. All right. So we almost costed ourselves there, students. Come on now. It just came back to me. So for this one as well, we now want to find angle at D, this theta. So anyway, which side and angle would be completely useless? It's B. The angle at B has nothing. The side at B has nothing. So it becomes easy. These ones can be eliminated, these two. So B, you're out. So that means for this question, we are using C and D. You now write for Cambridge to say sine C over small c is equal to sine D over small letter d. Now we want the big angle D. So yeah, it will be this one. So we'll take the small side D to the other side. We'll have small side D times sine C over C. This becomes sine D. Which is going to be, what is the small d? The young, let's label the triangle so that you can see it. This opposite big C is small c. Opposite big B is small b. Opposite capital D is small letter d. So our small letter d is 15.8. Okay. Times sine of capital letter C, which our capital letter C is 47. Come on. This is way too easy. Divided by small letter c, which is 12.1. This becomes sine capital D. What is this going to give us? What is this going to give us? 15.8 times sine 47 divided by 12.1. What is it going to give us, students? Put the answer in the chat. Come on, guys. Let's go. Move. You can do it. $0.95479. 0.95479 is sine capital D. Do you agree with this? Others, come on. Simon, where's your answer? Lehako, where's yours? Anita, where's yours? Mazrita, where's yours? Where's yours, Anu? Where's yours, Antonisha? What is happening? Antonisha, you've been quiet today. Where's your answer? Okay, 0.95479, 0.95479, 0783, 95499. Oh, 95499 instead of 79. 0.95499. 0.95. Make it long, Sarah. It's not yet the final answer. 95499. Oh, really? So let me do it. 15.8 times sine 47 divided by 12.1. 0.95499, not 79. Which means to get this capital letter D, we take sine to the other side. Sine inverse of 0.95499. This becomes capital D. What is that? Now do for this one, everybody. What is the sine? What is the second function sine of 0.95499? What do you get? 72.7 degrees. Do you agree? Come on. Anita? Yes, Simon? What is it? 72.7. All right. So 72.7 is D. But here they clearly said obtuse angle, which means it should be bigger than 90 degrees. Yes, it should be bigger than 90 degrees. So, yes, yes, yes. We should remember that when you do angles, the first answer is not always the final one, right? Good. So to get obtuse, I agree. Obtuse angle is the one greater than 90. So the only way to get it is to remove from 180. 180 minus 72.7. And what do you get? 107.3. There you have your final solution. 107.3. This becomes the final solution. Well, if they ask you for area of the quadrilateral, you say, ah, really? They're just asking for area of the two triangles. They should not try to pretend there's some big words here. Area of the two triangles. So can you find area of this one and then area of this one? So let's remove everything and let's see. Can we find areas of the two triangles? We can easily find area of ABD. You can say area of ABD, triangle ABD. This is just, we know what you do. You say this times sine this over 2 is the AB sine theta over 2. So it is 9.6 times 12.1 times sine 56 degrees all over 2. We get an answer. Can you hear me? Then this is for ABD. For the other one, which is obviously for this second triangle, we know this angle, which means we can know this one. Because this we just got to be 107.3, which means we can know this is the important one because it's the included one. We'll be now knowing this one and the angle, and we'll use the same thing. So you say 180 minus 72.7 plus the other one, 47 degrees. What is the answer to this? 180 minus this. We want to find the third angle. What is the answer? $60.3, which means area of the second one, which means area of BCD, triangle BCD. You can find it now. Come on now. Area of triangle BCD will be, since you now know that this is 60.3, you use this side, then you use the other one, then you use sine 60.3, then you divide by 2. So it is 12.1 by 15.8 by sine 60.3, then you divide by 2. What do you get? Tell me the answers, everybody. 83.03 here. What about for this first area? 96.02. Okay, so tell me. Let's do it in order. Let's be organized. For area ABD, what is the solution? Can everybody punch? For area ABD, please put a bracket for everything in the numerator when you're calculating. Open bracket 9.6, open bracket again, 12.1, close, sine 56, close bracket. Then you say divided by 2. What do you get? Then you do the same thing here. What do you get for ABD? 9.6 by 12.1 by sine 56, all divided by 2. What are we getting? Put the answers in the chat, everybody. $48.15. Okay. What about for the second one? Let's now do for BCD. Come on. Let's now do for BCD. $83.03. Yes. Yes. Mm-hmm. Why is it 25 points? Oh, yeah. Yes, you should use 107.3. You should use, you should get 25.7. Yes. Do that adjustment. What does the area now become? We should use the obtuse one. The area becomes 41.5. Yeah, so the area becomes 41.5. Are you sure, Simon? LGK, do you agree with 41.5? Okay. So now add them. What does this become? Okay. 89.7. 89.7. You're done. So triangles, really? Someone in this class to struggle with a triangle. Mm-hmm. Right. This is good. It's your turn. I've proved I'm done. I've done it. Now it's your turn. So, just like for physics, let me make sure. I was about to ask you for about the physics submissions. I need my physics work, everybody. You do May, June. Which papers have we done? Do May, June, paper 4-2, paper 4-3, paper 2-1, 2-2, 2-3. Triangle questions. So it's 1, 2, 3, 4, 5. I need to give you 7. And then you do February, March. (2025) paper 2-1 and paper paper 2-2 and paper 4-2. I'll upload them onto the Google Classroom for you. Same as for physics just now. I have to upload them since. Which ones did we say you do for physics? Can you remind me? I downloaded them earlier. Okay, it's fine. I'll check. I downloaded them earlier on. I want my work politely, please. I don't want an excuse. I don't want an excuse. Anybody, I don't want an excuse from anyone. It's exam season. You get up, you better get your hands moving and you do my work. That is how we work together. You do my work just like I'm helping you. So we have agreed. Let us agree to agree. Let me see what the register says. And who decided to be absent today? Let me stop the live. Goodbye, everybody on Streamland. Join Google Classroom again for register for those who are on stream.